Welcome to Unit 4, Lesson 5, Negative Rational Exponents Practice Problems. All right, we're going to have to transform these from radical form to exponential form. A 2 goes there, so this is 5 to the 9 halves. That's all we can do with that one. B. The exponent is 1, so this is 12 to the 1/3, but it got flipped upside down, so it's negative. And we can't reduce that anymore. Okay, now this one says, write 32 to the negative 2/5 without using exponents or radicals, which means we're going to have to take this one all the way down. So now, what I suggest you do is take 32 to the 1/5 power and then do it by -2. And why do I suggest this? Because 32 to the 1/5 power is 2. To the -2 is 1 over 2 squared, which is 1 over 4. If you were looking at this without separating this into pieces, you would write 1 over the 5th root of 32 squared, and then you would have to put that into the calculator, and that should give you a decimal, and then you hit math, enter, and you'll get 1 over 4. There's all kinds of ways you could do this. You could take 1 over the 5th root of 32 and then square it, and that's basically what I did in green. Okay, in this one, match equivalent expressions. So for A, the cube root of 8 equals 2. So that leaves us with A is 5. The negative 8 to the negative 1/3 is 1 over the cube root of 8, which is 1 over 2. So B goes with 3. Eight to the negative 1 is 1 over 8. C goes with 1. 16 to the 1/2 is the square root of 16, which is 4. So D goes with 4, 6. Okay, 16 to the negative 1/2 is 1 over the square root of 16, which is 1 over 4. So E goes with 2. And then finally, anything to the 0 power is 1, so F goes with 4. That's the only one left out. Okay. So it looks like as we go up the chart, what do we do? Right? Oh, they want us to write the fractions. So for this one, it's 27 to the 1/2. 27 to the 1/3 power is the cube root of 27. 27 to the 0 power. So it looks like the values of the fractions are going down. This is 1 over the square root of 27. And this is 27 to the negative 1/3. In order to know this last one, you're going to have to memorize the cube table chart. So get yourself an image of the perfect cubes. You should memorize them up to 10. It'd be good to have them up to 15 to 20. These numbers come up a lot in math and science classes. Okay, let's look at this one. So what are we supposed to do here? First thing we're going to have to do is multiply the trinomial because it's not equal to 0. So we're going to have to distribute both times. X times x makes x squared. X times 2 makes 2x. Negative 1 times x is negative 1x. Negative 1 times 2 is negative 2 is equal to negative 2. What I'm going to have to do is add 2 to both sides. Combine like terms, x squared plus 1x. Now that our polynomial is equal to 0, now we can factor it. Both of these have an x in it, so what I'm going to do is take the x out and be left with x plus 1. It's equal to 0. So when you have two factors equal to 0, set them separately equal to 0. And then solve each equation. So my one root is negative 1. My second root is 0. So these are the solutions to the equation. Okay, let's use exponent rules to figure out why the square root of 5 cubed is equal to the square root of 5 cubed. So if I write this, the first one, as 5 to the 1/2 power cubed, why is this equal to 5 cubed to the 1/2 power? Well, when I raise a power to a power, I multiply the exponents. 1/2 times 3 over 1 becomes 5 to the 3 over 2. So 5 to the 3 over 1 times 1/2 becomes 5 to the 3 over 2. This is why they're equal. Remember, with any whole number, you can always put it over 1. You don't change the value of the number. It's still 3. Any whole number can be put over 1. And that's the easiest way to remember to multiply fractions. Tops multiply tops, bottoms multiply bottoms.